In this example, we're going to go ahead and solve this equation, but if you'd like to try it on your own first, go ahead and pause the video and do so, and then come on back and we'll work it together. Okay, so looking at this equation, it seems like I have a few sets of parentheses here that I could get rid of, and I can do that by using the distributive property. So let's go ahead and distribute on the left side this negative 2 through this quantity, and on the right side this positive 2 through this quantity. So the 7k will come down, and so I'll have negative 2 times 3k, that'll be negative 6k, and then negative 2 times negative 1 will be a positive 2. On the right, 2 times 6 will be 12, and then I'll have 2 and a k, so 2k, and then this minus k will come along. Okay, on both sides you'll notice we have some like terms that we can combine before continuing. So 7k minus 6k will give us a 1k plus 2, and then we have our 12 plus, and then 2k minus k will just be 1k. So each side has a k, and then I also have plus 2, and then here I have a positive 12. Let's go ahead and subtract k from both sides, because I notice that those will cancel. So the k's do cancel, and I use my subtraction property of equality to do so. So I'm left with 2 equals 12. Well, what happens in a situation where you have yourself an equation and you work your properties of equality like you're supposed to, but then all the variables cancel out? Well, then you have to think about, what am I left with? Is this a true statement or is this a false statement? Well, does 2 equal 12? Indeed, it does not. So we say this is a false statement. So what does that mean ultimately? Well, it doesn't matter what value I plug in for k. All of those values will ultimately cancel anyway, and I'll always be left with this false statement. So if that's the case, that means this equation actually has no solution.